thanks a lot, Altium, for giving us a chance to speak more simulation, because I think that's something we need to get out into the world, not just in Australia. Simulation is useful and important and increases the product quality. So we would like to show today a couple of things that, I mean, ANSYS has done similar sessions so far about that. And we would like to show a little bit of where we are coming from, how the bridge works, how the connection to ANSYS work, and then a couple of aspects and background info about simulations and how we approach it. Just about Leap in a nutshell, we are basically a company that does software solutions for smaller companies or even multinational organizations. We're providing modeling tools, but then also tools that can analyze those models, and then further up even into product lifecycle management systems. We can also build digital twins, for example, or augmented reality from those models. So the palette is very, very broad, but we have a electromagnetics team that is helping customers to build workflows and give solutions in the space of EMC and EMI, in the space of PCB design, but also manufacturing. So for example, we can actually simulate soldering processes of PCBs and look at what the solder does and what the stresses and strain do as well. So broad applications to serve the Australian markets more on virtual test schemes. This is a couple of trends, because we see a lot. So if you, for example, do, and that's 4 of the specialties we do, there are many more. If you, for example, do magnetics designs yourself, that might be a good solution for you. We have a little app that taps into bobbins and core libraries from TDK and EPCOS. And if you put your voltages and your currents in that you would like to see, the software assembles those inductors or electrical transformers for you and finds out what the best design is in terms of losses and gives that back to you so you can use it. It's maybe good in comparison to off-the-shelf components if you want to design your own. Then, of course, the PCB-related simulations we do as well a lot, starting with filter design, vias for signal integrity, but going up to multi-layer PCB simulation and then putting the board even into chambers and enclosures to look at, for example, electromagnetic compatibility, shielding effects, and so on. Then there is a very strong power electronics workflow we have. So we are able to merge highly dynamic power electronic semiconductors with parasitics. And the parasitics can come from everywhere. They can come from a cable, they can come from a package that you see on the screen, and even they can come from an Altium board. So with that together, the highly dynamic semiconductors plus the parasitics in your circuit, you will have a very, very accurate model that even can be used for conducted emissions, for example. And then the last one, the communication systems, of course, antenna design and antenna array design is a topic for us, especially with the defense industry in Australia. But then also mounting those antennas onto towers or onto other platforms, looking at RF cosine interference, RATAs and all those things, especially in the defense area, we can help with that as well. So the cool thing about that partnership between Altium and ANSYS is basically, if you have done your Altium board and your design, you've pretty much done more than 50% of your virtual prototype already. So that, and I will show you that later, that can be ready in no time for simulation. To improve board quality and product quality, of course, there are many things to consider. There's mechanical topics, there's also thermal topics, and then the classical electromagnetic topics. One specially we do is even diffusion, so we can model moisture absorption in different materials. So if you, for example, put your PCB into a package and ship it for 6 weeks, sometimes there is a warping or a deformation included. We can capture that and forecast those things as well.